We are supposed to be, yes. All right. So we're going to prove this just for practice. When you do these in the homework tonight, you don't necessarily have to prove equations, but it might be a good idea, especially if you're going to be doing a retake, to go ahead and do the proof process just so you get used to the process. This is like a Bluetooth. It's hooks the computer, it acts as a microphone.
Does the video camera on it? You can see me right now?
No.
Oh, it just hears me.
No, it just hears you. It's a microphone. All right. So, try again. There we go. So we'll make this step one. Reason one would be? Given. Okay. Step two. Combine the like terms. So what would I write down? Negative 2x plus 9 equals 5. And what is our reason when we combine like terms? Substitution property. And we did it twice, so times 2. All right? Notice I did subst, not just sub-prop. I did have some people on the test who are on the benchmark who did just sub. And sub could mean subtraction or substitution. It's vague, and we want you to be specific. So make sure you're using the correct abbreviations. Step 3 and reason 3. What are we going to do? Yep, and so negative 2x equals negative 4, and we did subtraction property. And then finally, x equals just 2. Divide by negative 2. And so we did division property. All right. That's how we prove these equations. Some people are having difficulty, I could see from the homework, with the equation solving portion of it. They couldn't combine like terms, or they would add 9 to both sides and get 14 instead of negative 4. If you're struggling with equation solving, be sure you're getting yourself in for some extra help, because, wow, that's going to be huge. We're going to be doing it all year. So you need to be solid on that skill. I mean, I understand sometimes we just make stupid mistakes. It happens. But if you really don't know how to do that, or if you're struggling with it, please come in for some help. Let us get you on track with that. You knew how to do it at one time if you got through Algebra 1. Yes, Nick?
Instead of doing a substitution, can you just do 2 more steps and do addition, subtraction, or whatever it was?
I could have done subtraction and then another subtraction, but honestly, eventually I'm going to have to do a substitution to combine these terms. We always combine, remember, when we're solving equations, it's distribute first, then combine like terms, then undo addition, subtraction, and finally undo multiplication, division. Those are equation solving steps. Simplify, you start by simplifying by distributing, combining like terms. Those are what we do first. All right? So that kind of gets us going with some of the stuff we're going to need for today. Today we're going to talk about angles. Parts of angles, things like that. Let me just zip ahead to the next slide very quickly. Most of you are familiar with this stuff about angles. In fact, you probably learned this in like, what, 3rd, 4th grade? Not a big deal. We have obtuse angles, acute angles, right angles. What's the measure of a right angle? 90 degrees. We put the little box in there to indicate that it's a right angle. Okay. This is a straight angle. We haven't probably talked much about those, but they're exactly 180 degrees. Right angle is 90 degrees. What's an acute angle measure? Okay, so the angle is less than 90 degrees, but it has to be greater than what? Not 45. Well, no, it could be less than 1. It has to be greater than 0, right? Okay, I'm just in here. There's some. All right. has to be greater than 0 but less than 90. How about obtuse? It has to be greater than but less than 180 degrees. Okay? So, again, you understand what these different designations are. Some people sometimes mix them up, which is why we put them out here. Every once in a while I get somebody who gets confused between obtuse and acute. And just remember, other ways you can look at things. I always like to think of acute as it's acute, like a cute little angle. Cute things are, generally small things are cute. We refer to like little things, baby animals, stuff like that as cute. See? Cute, little, acute, small angle. Okay? Obtuse is an adjective meaning thick or difficult to deal with. If someone is being difficult to, uncooperative might be another word for being obtuse. Okay? Only if the shoe fits, my friend. Only if the shoe fits. All right. So, obtuse people, large, you think large, difficult to deal with, big problem, big angle. Yeah. Most people would say it refers to their teenager. But, yeah, it's okay. So let's talk more about angles. Yes. If you absolutely must.
No.
No, I only beat out once today.
What is with you today, man? Who put a nickel in you? Nick. No wonder. Okay. Let's talk about the parts of an angle, because you've probably never thought of angles as having parts before, but they do. And some of the very first homework problems you're going to see tonight are going to talk about parts of an angle, and these are great basic level test quiz questions. An angle is made up of two rays with the same vertex. That's what makes up an angle. We have two rays, so I'll call this point X, this one A, and this one B. So the angle is made up, its sides are the rays XA and XB. So the sides of the angles are rays. The vertex of the angle is just the point X, in this case. That's the point. You wouldn't necessarily need the quote marks, but I'm putting it there to make it clear. Yes? AB for the sides? Well, okay, but ray AB would be the ray that goes like this.
Oh, yeah, that's right, never mind.
That would be ray AB, and that's not the angle that we're dealing with.
Yeah, okay, I was just going to say the accident.
Yeah, we always need two letters for the ray, the beginning point and some point along the way. We have an interior of the angle. The interior is always going the short way. The exterior is always going the long way. We do not, in geometry, very often deal with angles greater than 180 until we get to our unit on circles in fourth quarter. Then we go up to 360. And then if you go on to trig beyond that, then you can actually get negative measure angles and angles in different measurement systems. Yeah. As long as you consider an angle being caused by rotation, like if you rotate one way it's positive, the other way is negative. So that's trig though, and pre-calc. So you got a ways to go before you have to deal with that. For us, we're generally between 0 and 180. Measuring the angle, pretty easy. We take the protractor. You have to do a couple measures today. I've got a couple extra protractors sitting here for that. If you don't have a protractor, you get home and stuck, just estimate as best you can. All right? It's okay if you don't have a protractor. You should be able to look at an angle and think, gosh, that's about 60 degrees. That's about 75. You've been doing this long enough. But, again, we put that vertex, or that dot on the vertex. We line up one side. We do the best, we try to do the best we can to get it just right on. And then we measure, starting at 0 and counting up. So 0, 10, 20, 30, 40. Looks like about 42, 43 degrees. Let's say 42.5 degrees for that angle. All right? And that's how we measure angles. Now, that's generally not a test question in here, but it is something that we'll be doing with the WKCE when you take it later this year. Almost every year the WKCE has a couple problems that make you measure angles with a little protractor. They give you little protractors, they measure angles to see if you know how to do that. So it's a skill you do need to be able to use on a test this year for a lot of you. Naming angles. To name this angle, we name it using points, the vertex being the key point. I always start with an angle symbol when I'm naming an angle. That's what an angle symbol looks like. Very simple. I could call this angle AXB, angle BXA. Either name would be fine. Now, what if I forget the angle symbol? Well, then I'm listing 3 points, and 3 points make up a plane, so maybe I'm talking about plane XB. Maybe I'm talking about triangle AXB. I don't know. If I don't use a symbol, I don't know what you're talking about. And for planes even, we use the word plane. We don't have a symbol, but we use the word plane to describe it, so I can tell what I'm working with. The third way we could possibly name this, I could just call this angle X. Name it solely by its vertex, which, since it's the only angle X in the picture, we can get away with. But we want to be careful, because if we get a situation like this, and all I said was angle C, well, which angle C do I mean? Do I mean angle ACR, this first one, angle RCM, the second angle here, or the whole thing put together? What do I mean when I say angle C? There's more than one angle C, right? Again, our name becomes ambiguous if there's more than one angle at that vertex. So if I was to name angles here, I would definitely use 3 letters to figure it out. And again, when we use 3 letters, the second letter is always the vertex of the angle. So angle AXB would not be the same as angle BAX. Angle BAX would be, this angle right here. All right? So I can have, if I rearrange the orders of my letters, I do change the angle I'm talking about, depending on how I rearrange it. So that's the different angle ways that we name angles. Working with angles. And the idea of angle addition. This is important. Almost always we're going to learn concepts about things, and we're going to go right into algebra and setting up and solving equations. That's a pattern you will see for the rest of the year. We will be setting up and solving equations. So we learn some facts about algebra, then we use it to apply. In this case, look at the information we're given. The measure of angle ACM is 140 degrees. What is the value of X? How am I going to find out X? Well, this problem, like many problems, has basically 2 choices. I could decide somehow I know these 2 things have the same measurement. And I can't make that decision based on just looking at it and saying, they look about the same, okay. We have to have a fact that lets us conclude that. Is there any fact here that tells me that these are the same measurement? No. What does my fact tell me, in fact? It tells me that the measure of the large outer angle is 140 degrees. So instead of setting those equal to each other, what does that suggest we might want to do from an algebra standpoint?
Just figure them both out and then not have it.
Okay. But if I put them both together, what do they have to equal? 140, yeah. Yeah. If I take this plus this, it has to equal 140. So 2x plus 10 plus 4x minus 3 is 140. So that gives me 6x plus 7 is 140. So 6x is 133. And divide by 6. $133.6. Now that's not going to reduce, is it? It's okay. What we don't want to do is we don't want to make assumptions that are not supported by facts. That's the whole deductive reasoning process here. A lot of people will look at this and say these two are equal to each other and solve the problem that way. Because they looked at it and said, gosh, they look about the same. We do not go based on looks. We go based on facts. And the facts tell us that the measure of the outer angle is 140. So we added them together and set them equal to 140. And that's fine. That's one of our major ways of doing things in here. We'll be doing this all year long. You ought to become very accustomed to it over time. Sometimes you set them equal to a total like 140, sometimes it's 180, sometimes it's 90, sometimes you're setting them equal to each other. Every problem's a little different. You have to figure out how to set up that equation. And then you have to execute it. Congruences are going to be a huge idea for us. First off, the symbol for congruence is right here, but it's a little hard to see, so I'll make it bigger. It's an equal sign with a little squiggle over the top. It means equal and similar to at the same time. Congruence does not mean the same thing as equality, although congruence includes equality in its definition. Congruent means has equal measurement. So I could get two desks that are congruent to each other because they have exactly the same measurements. These two desks are probably pretty congruent. If I measure the desktops, if I measure their heights, if I measure the chairs and everything, they're pretty much the same. So I'd say they're congruent desks. However, they aren't equal desks, are they? I mean, start with this one's over here, this one's over here. Equal means exactly the same. It means physically exactly the same. In the same space at the same time, that's equal.
So nothing's equal?
Numbers
Well, not exactly.
are equal. Yeah. So things are generally not equal. Numbers are equal. Things, like an angle or a desk, are congruent. A couple of identical twin people, not really things, they're people, but you get the idea. They are congruent, but they are not equal. They are not the same person. They might look exactly the same. Okay? They have a lot of similar traits and similar genes, but they are not the same person. I mean, if you had an evil twin brother, identical twin, who went out and burned down the Milton Police Department, okay, you wouldn't go to jail for it because you're not the same person, are you? Okay? Unless you were helping him, in which case. All right, so anyway, congruence is for objects like angles and segments and things like that. Equality is for numbers. Now, congruence means has equal measure. So they are related. Okay? Congruence means has equal measure. That's a good one for your note card. And by the way, maybe tomorrow I'll be coming around and doing a special check of note cards. Because I notice a lot of people seem to be kind of being lazy on those. So I will be coming around and checking and make sure you have your note cards with you tomorrow. All right? I want to see what you've got done so far. Numbers tend to be equal. Objects tend to be congruent. That's what we're going to work with. And we'll work on this all year long. Don't worry. You will mix it up. I will mix it up once in a while. I'll say the wrong word once in a while and go, no, the other way around. And if I can do that after this many years, I'm sure you're going to mix them up once in a while too. Just always be thinking about it. These numbers, are they the measurements of the things, or are they the things themselves that I'm comparing? Now, one way we can deal with congruent angles is by bisecting an angle. Bisecting. Bi is a prefix meaning what? Two. Bicycle, right? Two wheels. So, an angle bisector is a ray, so it's not a line, it's a ray, that goes through the vertex of the angle and splits it equally into two parts. That's what a bisector does. We indicate the congruent parts by these little arc symbols here. All right? That means that this is congruent to that. So it's dividing it equally. That's what a bisector does. The angle bisector, however, must always be on the interior of the angle. It does no good to have the angle bisector, try again, say out here. Maybe these two angles are congruent that we've come up with. They're both obtuse. Maybe they're congruent. But if I put them together, I don't even have an angle anymore, do I? Put them together, I've got the opposite angle. So we only deal with angle bisectors of acute angles for this. Put that back. Okay. That's what an angle bisector does. It is a ray, not a line, not a segment, not a point, not a plane. It is a ray that goes from the vertex of the angle all the way through the interior of the angle, dividing it equally. Okay, let's take a look at another problem. I'm going to draw something else for you. We've seen this picture before. Let's get the same numbers in it even. 2x plus 10, 4x minus 3. And now we're told that AX ray bisects angle WQY. WAY, excuse me. It's an A. What does that mean to my equation? It's a bisector, yeah.
It means the AX splits the angle.
It splits the big angle equally, doesn't it? And how would I set an equation up using these variable expressions now? It's being split equally. Those two must be congruent, which means their measures are the same. They're equal to each other. So I'd say 2x plus 10 equals 4x minus 3. Now you're saying, wait a minute, that picture's kind of familiar. Absolutely it is. It's the exact same picture I had back here. But notice I had different given information, didn't I? Do not assume you know what's going on based just on the picture. If you see a point on a segment, don't assume it's a midpoint right in the middle unless you see something that tells you it's a midpoint. It might be, it might not be. It might be off just a hair. You wouldn't know. Here we're told it's a bisector. So I set up the equation and I solve. 2x plus 10 equals 4x minus 3. So I subtract the 2x from each side. I get 10 equals 2x minus 3. Add 3. 2x equals 10. X is 10/3. All right? I'm sorry. I zoned there for a second. 13 halves, isn't it? My bad. 13 halves. I knew something was wrong there. I started thinking about something else in the middle of doing a problem. Shouldn't do that. X is 13 halves. So again, setting up and solving equations. When you look at tonight's homework, most of it's pretty simple, naming just parts of angles, stuff like that. Only the last 5 problems involve any math at all, as far as adding, subtracting, multiplying, dividing. The 3 through 26, again, it seems like a lot, but most of it's going to be really, really fast. And remember, we're kind of skipping around a little bit here. We went from section 1.1 to 1.4. Tomorrow we're going to jump ahead to 1.6. And we'll take it from there. But there's plenty of stuff here to keep you busy, keep you going. Don't forget to be doing those corrections so you can take the retakes. All right? Stay put till the bell rings, please. It's not going to be long.